Hey class, we're going to move on to section 2.4, measures of variation. Last we did center, so now it's variation. How does a data set spread about the mean? Right, so how it's distributed, dispersed, how far apart are the data points from each other? Is there any measurements that we could use to do that? So some common measurements are the range, which we've seen before, and then we're going to get into what are called variance, standard deviation, and eventually the interquartile range. But remember, just to remember the range, here's our formula for it. It's the max minus the min. All right, so we've done that before. And then we're going to try to dive into variance and standard deviation. But to start us off, let's do an example with some receipts from one night at a restaurant. And for calculation purposes, let's call this a population. So it's all the receipts, right? So it's a population, not a sample. Let's find the mean, median, and mode. Okay, so the mean, for population mean, remember we use mu. So we've already done this, so I'm not going to waste time calculating it. If you add them all up, you get 454, and there are 10 numbers. So the mean is 45.4. Okay. And then the median, if you put them in order, find the middle one, you'll get 45. You can practice that on your own if you'd like. And then mode, there's two of them, 42 and 50, both repeat twice. Okay. And then also the range. Let's get the range as well. The biggest number we see is 56, the smallest is 38, which if you subtract them, it equals 18. That's what I meant. Okay, so there we go. Those are our values. That's all review. Now we're going to use those numbers, some of them, to do a new measurement. Okay, so how spread out is this data set? That is the key to all of this. Right. Range is one way. I mean, we could say that the range is a measurement of spread, but it only uses two entries. It doesn't include anything between. Right? We want to find a measurement that uses all the entries, and we're going to call this the standard deviation. Right? It's kind of like an average deviation from the mean. You can think of it as a type of average deviation away from the mean. So to do this, we're going to build the formula. If you want to look in advance, the formula is down here on this next page. Population standard deviation is this guy. Right? So this is what we're going to be doing, and there's a lot involved in that because there's that summation. So we have to subtract x minus mu's, square them, sum them all up, divide by n, take the square root. So in order to do all that, it's best to make things organized in a little table. Okay, so here's the process. You put all your data values here. It doesn't really matter the order, right? We're just putting them there. And then the first step is to subtract the mean from each of those, right? So for each one, we're subtracting the 45.4, right? That's the ticket. All right, so if I do that, the first one, I'll show my work. So again, what I'm doing is 44 minus 45.4, and that equals negative 1.4. Right, that's called a deviation. It's a distance from the mean, right? And we're going to do that for each of the values. So you can check my work on this. But if I subtract 45.4 from 50, I'd get a positive 4.6. Next, I would get a negative 7.4. Some of them are going to be negative. Some are going to be positive. It just depends if it's less than the mean or greater than the mean. 47, if I subtract, I'll get 1.6. There's another 42, it would be the same. This will be a negative 6.4, 0.6, and then finally 4.6. All right, so those are the deviations. Now, I guess I could find just the average of those, but if I add all of those up, I actually get 0, because some are negative, some are positive, and so it doesn't really do me any good. So a technique used in statistics is to square each of these numbers, because that's going to kill all the negatives. So that's what this step is right here, right? Take each of these numbers in this column, right? So I'm taking now all these numbers, and I'm going to square them, multiply by itself. Now, remember, if you do a negative times a negative, it's a positive. So you know everything is going to be positive. So when you do the calculation with your calculator, don't even worry about the negative. Don't put it into your calculator. Just go 1.4 times 1.4, or 1.4 squared. You know, if I were doing this on my calculator, if I had this type of calculator, right, 1.4, use this square button, which is right there, right? I'm putting it, whoops, way too many because I held it down, but I was just trying to indicate where it was. It's that button, right? So I'll probably clear that, but 1.4, hit that button, and then enter. Or you could just do 1.4 times 1.4 if you can't seem to find your square button, right? So you get 1.96. Oh, advertisement for Angry Birds 2, I guess. You always got ads when you're using some free apps. Okay, so that was 1.96, right? 1.96, okay. And we're gonna do it for every one of them. So I'll just go ahead and fill these in. You can check my calculations if you'd like as I do this, or you can just fast forward because this is pretty boring. Almost there. Okay, once we have them all done, those are all your deviations squared. Okay, now we have a new list of 10 numbers. And now what we're going to do is sum them up, right? Summation. What we're building is the top portion of the formula, right? That's what we're getting out of this table once we sum all of those up. So I'm just going to add them all up, and turns out that grand total is 278.4. Okay. Okay. And now let's go down. I'll keep that in mind. That's not anything yet. That's just part of the calculation. But that's how you're going to start it off. That's most of the work. It's just filling out that table. Now we're going to do formulas. Okay, we have formulas for variance and formulas for standard deviation. Notice they're pretty much the same. It's just the standard deviation has the square root, whereas the variance does not. But underneath, this piece right here is the same in both of them. There's a new variable for it. It's lowercase sigma. So this variable here, you see it has a square on it. That sigma squared is the notation for variance, whereas standard deviation, the notation is just sigma. Okay, so these two are related very closely, right? If you take the square root of the variance, you get the standard deviation. If you square the standard deviation, you get the variance. Okay, so use the table on the previous page to calculate the population variance and the population standard deviation. All right, so for variance, let's do that one first. All right, the formula is this. But that whole table was finding that top piece. That was the 278.4. It's that whole top number. And the capital N is how many data values there were. If I do that division, I get 27.84. That's called the variance. Right. Variance is not used a whole lot. The one that's more commonly used is standard deviation. The reason is because standard deviation has the same units as the original data set, whereas variance does not. This number here is actually in square dollars. Right? whatever that means. So I want to convert that back to just dollars, and that's the standard deviation. So standard deviation is, now we're going to just write sigma, right? And it's basically just the square root of that exact same thing we just found, right? And we know all that, it's 27.84. So I just got to find the square root of 27.84 and round to 2 decimal places, it says there. So 5.28. And that would be in dollars. $5.28. I could even put a dollar sign if I really wanted to. Right? And that's the standard deviation. To interpret that number, that is the approximate spread. So on average, a restaurant receipt is going to deviate from the mean by about $5. Right? Average deviation from the mean. Okay, well, good times. What else do I want to do? Now, one little thing. Sample variance and sample standard deviation have slightly different formulas. One, because there's different variables, but also there's this denominator with an n-1. Right, population was just n. For variance, it's n-1. Right. And the difference is to compensate for greater variability of sample data. So that's why it's done. But it's just something to remember if you have to find sample standard deviations. Okay, so let's try another one, and this one we're going to do, it's the calculation's pretty much the same, it's just we've got to account for that sample adjustment. Okay, so here we have weights of 7 adults. So back to the drawing board, right? First thing we need is the mean, and I think we found this mean in the last section, but I'll just write it here. If you add those up, divide by 7, you get the 258. Okay, so what do? We're going to take each of these values and subtract 258. So 274 minus 258, 16. So again, going through, just subtract 258 from each one. This one you'll get a negative 23, and I'll just fill them in. 10, 32, 27, negative 27. Okay, those are the deviations. So next we need to square each one. So 16 squared, 256. All right, used to this process. Okay, and then we add them all up, so there's nothing different than what we did in the last problem. Right, add all those up, you should get 4,592. Okay. Now we need to get the sample variance and the sample standard deviation. Okay, the notation for sample variance is s squared. Right, I'm just kind of following this formula up here. It's, if I rewrite the formula, again, that top piece, this is what we just found with the table, right? So I'm going to replace that whole top thing with the 4,592. The n is how many data values there are, which is 7. But then here I got to subtract 1 because it's a sample. So sample, subtract 1. If this were a population, considering in a population, you would just leave it 7. So that's the one little tiny thing about sample. All right, so we're going to do 4,592 divided by 6, which is about 765.3 variance. Okay. Standard deviation is just S. And whatever I get up there, I'm going to just take the square root. So it's the square root of the variance. 765.3. Now I want to be a little bit careful here because I did round that number. It's actually 0.33333333333. So I'm going to include a few extra threes when I do my calculation so that I don't get some propagated error. And this is about 27.7. Right. So on average, these data values are deviating from the mean by about 27.7 pounds. Okay, we'll finish off this page and then take a little break. Just a summary of variables. Variables being used. There's lots of them floating around now, right? Variance for the population is sigma squared. Standard deviation for the population is sigma. Mean is mu. And the number of entries is capital N, population size. For sample, all that changes, right? If you're talking about a sample, the variance is S squared. Standard deviation is just S, mean is X bar, and sample size is lowercase n. So that's good to have all those clear because they pop up everywhere throughout the rest of the semester. And if you're always wondering, what does S mean again? It takes a little more time and gets a little more confusing. So if you have those down, it's helpful. Okay, we'll continue with this section in the next video. Thanks for making it all the way to the end.